Hi, this is Takuma Nakata. I'm an instruction designer based in Kyoto, and welcome to my vvvv beta graphics tutorial. So this will be the last episode for the FieldTrip packs series. I didn't know it's already been my fifth tutorial out of FieldTrip. And in today's tutorial, we'll be covering a few different two-dimensional things. Well, it's not actually two-dimensional, but I would say two-dimensional, since the ones that we've been following was more based on spheres or like vector field, which is based on 3D stuff. And I realized that I wasn't sharing anything related to 2D, SF2D. So I'll be covering that part. In the same time, we'll be learning about domain or repeat things as well. A bit heavy, so my OBS is sort of like drop framing, but anyways, this is the first result that we'll see, and the second one is this one is based on SF2D, so I'll just delete this one just in case, because right now it's too heavy. I'll just lower down the resolution. Okay, so this should work. So yeah, this pattern is generated on the right side, so it's using the SF2D function to get this kind of result, which is quite interesting. So if I, for example, delete this one, so this kind of pattern can be generated, and of course it's all procedural, so you can actually move around the values and change. So if you're interested in generating patterns inside vvvv, I think this FS2D is really powerful for that. I'm also like overlaying different patterns so that it looks a bit different. Also, you can scale up, scale down, and generate sort of like your favorite pattern just inside vvvv, which is quite handy. And the other one is on the left side, and that's the one you saw at the beginning. So it's this one. So what it's basically doing is it's repeating the hex prism. So hex prism in default is just a prism, sort of like a torus, like this one. I've added some noise onto it, so it looks a bit different. But then if we use this domain repeat thing, it keeps repeating the prism so that it looks like your entire field is covered using this hex prism, some other noise. And the cool thing about ray marching, or like this field pack is that it's based on ray marching, and ray marching is not something that you repeat. If it's a geometry based thing, you have to repeat and copy your geometry, so it gets heavier and heavier as much as a repeat. But ray marching is more based on like what you see from your camera or from your perspective, so you can actually keep repeating it entirely. For example, if I turn off the blur right here, and right now I'm limiting the render view to 10, so it crops in some point. But if, as you see, if I keep moving the camera, it keeps showing the pattern entirely, so it's almost like an infinite terrain. And I don't see my computer kind of like crashing while I'm moving my camera. But of course, as I said in my previous tutorial, this is based on the resolution, so the pixel resolution. So if I increase this one higher, then it sort of like gives you this slow result. So if you don't have a strong machine, I highly recommend decreasing this march max distance. This will help a lot. So yeah, let's get started. So just save this one and start everything from scratch. So as always, we will need a renderer, but as I said, ray marching is quite heavy based on the resolution. So I'll use the render MRT, which is this one. And then I'll set the resolution for like 800 to 800 for now, and then I'll add a preview here. So right now it's in blank. So first thing I'll do is I'll use ray marching basic, and then I also want the aspect ratio to be correct, so I'll use an aspect ratio X11 layer. So now At the moment I have nothing here. I'll just make an order. So first of all, we'll be doing the SF3D one, so the domain repeat on 3D stuff. So, and then I'll need a hex prism here. So, okay, the hex prism. I'll just control the scale and things later on. I'll just see what happens if I plug it. Oh, I also forgot the camera, so I need a camera orbit. Okay, so this seems like how the hex prism looks like. I'll make it a little bit thinner. And I think the lens is okay. So right now, this hex prism is the only guy who's in this world. And let's see what happens if we add a domain repeat. Domain repeat. So there's different types of domain repeat. So today we're using the SF3D one, which is the second one. And we'll try connecting this one here. And as you see, if you see the input of domain repeat, there's two different input, which is the size XYZ and the repetition operation. So we'll change this one for to wrap X and Z, because we want this to wrap only on X and Z axis. We don't want it to repeat on Y axis, because then it's gonna be more like a wall. So we change this one to X and Y, and let's connect that to ray marching basic. As you see, that was pretty fast. So it's already repeated to the entire field. So now that I keep zooming, it goes entirely. Like, you can go as far as you want. It's pretty cool. So, and if I change, for example, the scale of the hex prism, it all changes in real time altogether, which is quite amazing. So if you have, so for example, if you have a certain pattern that you want to repeat in 3D, this is definitely the tool that you should use. I mean the node that you should use. For example, if I change this one to X and Y, what happens is that it goes to the Y axis, so it creates this kind of wall. And this is also cool, but it's not something that I want for now. There's also different types. If you change it, you can see what they do. I haven't checked all of them. But this one seems like they're all mirror, seems like it's doing kind of the same thing as the wrap, but probably it's not the same. But I know we'll keep us stuck with the X and Z. Okay, so this was the first step, and there's different type of domain, blah blah blah. And there's also domain distort, domain lookup, domain mirror, domain repeat, domain transform. Domain repeat is what we're using right now. I think domain mirror kind of does the same thing. A domain lookup, it's replace the domain of a 3D scalar field with a 3D vector field. So it uses vector 3D VF3D as a domain and converts that to SF3D probably. Not sure, I haven't opened it up, but I'll try connecting this domain distortion SF3D, and I'll connect this one to, I think I'll connect this one to the domain repeat. And if we check the input, it has one distortion function for the VF3D. So we'll try see what happens if you connect a node VF3D, noise VF3D, which is this one. Let's see what happens. And then we'll connect this one here. Okay, so now this noise from domain distortion got connected, and it's distorting the entire hex prism. The cool thing is it's not affecting, they're all not in the same shape, and that's because it's right after domain repeat. So domain distortion is applied to entire field that we created through domain repeat. So if we reconnect this one, and if we change the order from hex prism to domain distortion to domain repeat, and then to remarching basic, I think the entire hex prism, entire hex prism would have a same distortion. And if this is the result that you want, this might be the right order, but for now I just bring it back because I want the entire field to be distorted in different shape. Okay, so this is already looking pretty cool. I think I'll change the height a little bit. So as you see, it's getting affected by the noise. noise from vector field. So as high as it goes, it doesn't have the same kind of noise, but it keeps changing, which looks pretty cool. So yeah, this is, I think, what I want to share for today. And the first step, so I'll just reorder this one. So this domain distortion and this domain repeat is really powerful if you want to have like an entire field generated by a certain pattern. Also, if this goes too heavy on your machine, please make sure that you change the value for this March max distance. Right now, it's sort of like rendering the entire viewport and you don't see how far it is, right? But this makes your computer pretty heavy. So if you decrease this one to, for example, 20 or 10, as you can see, it's only rendering the part that it's like this far, and it doesn't preview the ones that's further than that, which makes your machine work better. Okay, so that was the technique I wanted to share. So the first one, and in addition to that, I also figured out this depth of blur effect using this basic blur node. So I want to share that just in a moment. So we'll be using the basic blur DX11 textured FX node from DX11. This is one is in default, I guess. Yeah, DX11 packs. So in basic, if you just connect the blur to the preview, this is the result that you get. The entire scene will get blurred. But if you connect the depth to it, so first of all we have to change the render to standard so that we get the depth buffer here. If you connect the depth buffer, as you see, it sort of like changed something, right? So now the near plane is not as blur as the far plane. But this is not enough because we want to control how far the blur will affect. And to do so, we'll need a linear depth node. So it's this one. I think this one is also from inside the DX11 packs. If you connect this one to depth, and then if you connect this one to blur, now let's see what kind of texture we're getting from it. So in default, the depth in default is exporting something like this. So this is a texture that we were connecting to the blur, but this wasn't enough. So we need to tweak this a little bit to make it more accurate. So what we'll be doing here is, first of all, we need to connect the projection, so where the camera is. So now, as you see, it changed, and it seems like this control texture doesn't have to be red. It can also be black and white, which is pretty nice. So once I connect this projection from the camera here, did you see that it changed something? So now the blur here is more nicely blurred. So only the far part is blurry, the close part is not blurred. But the blur looks a bit low quality, and that's because we have to change the mode on the blur. So right now it's fast blur, but I'll change this one to 3 pass blur. Now this blur looks a bit more soft and nice. And we can also control like how far from which further point you want the blur to start, and this max depth is the one to control. So if you decrease this one, it gives you more like a strong lens effect, and if we increase this one, it goes further. So this is a really easy way to add a depth of field to your visual. So I just wanted to share that. And there's two different techniques inside linear depth, which is the depth threshold and the linear depth. If you want to wrap the red depth texture, then this one is the one to use linear depth, but you can't really control the max depth on the linear depth. So instead of that, let's use the depth threshold to add this kind of like depth of field effect. Okay, so that was how to add a depth of field on your visual. But anyway, let's go to the next part. Next part is the HeighFieldSDF. So we'll be adding this one. And I don't think we'll need this one here, and it also makes it really heavy if we have two different things working on the same time, so, and I don't want that, so I'll just delete the entire things that we just created, and we'll just need this HeighFieldSDF. So what HeighFieldSDF is doing is it has an SF2D input and it outputs an SF3D. So based on so for example, based on a texture, it creates a SF3D height field. Let's see what that means. So first of all, we'll try connecting noise FF3D, and let's check SF2D. I think it should draw. Yeah. So, let's see what kind of image it's drawing. So this is the noise. So it should be a 2D noise, and then draw SDF allows you to preview the result on the render. So we'll just connect the vvvv stuff in default render here and right click here. So this seems to be the kind of noise that this noise FF2D is right now generating. So if we change the frequency, it changes. If we change the amplitude, it changes. Center. So try to figure out the shape that you want to use for now. Okay, so I'll say this is what I want. And then what we can do is we can connect this one to HeighFieldSDF, and then we'll output this one to rain marching basic. Takes a bit of time, but once it's done, see this pattern that we generated here is converted to a SF3D height map. It's pretty hard to see if it's exactly the same as what I created here, but I can sort of feel that it is. I don't know how correct that is. We can also change the amplitude on the height field, so if you want to make it higher, we can make it higher. We can also change the orientation, so if you want this to be on the X like a wall, then we can do that kind of stuff. So Z-axis. But it doesn't really look good, so I just stick on the Y-axis. Just delete this one. Okay. And this is also, I think this one is also infinite, so this height field is generated like in an infinite area, which is also pretty cool. It's like a terrain. Okay, so these two are the nodes that I wanted to share for today. I'll just turn off this blur because it's noisy. Okay. So these two are the domain distort, domain repeat, and this HeighFieldSDF is something also really powerful. If you haven't tried, I would highly suggest you to try and figure out what kind of visual you can create out of it. Okay, so this was the first part for the 3D part, and then in the followings we'll work on the 2D SF, which is basically using the SF2D node. Okay, so since we're moving to the SF2D, I'll just delete this patch and start everything from scratch. So first of all, we're gonna be using the node called SF2D, which are listed here. So if you type SF2D, you'll see all the surface field 2D nodes here. I'll do this really quick. So it's same as the domain. We're basically using the same node that we did for the SF3D 2D, but we're using the node on which is for the SF2D. And there's only a few nodes, really important ones that I should mention is the draw SDF. So using this one, we can preview the 2D SF2D in real time. So we'll connect this one here. And for now, I won't specify any resolution for the render because this SF2D is way lighter than SF3D. So I'll do it really quick. So we'll be using a circle SF2D. So we'll be using this one and triangle. There should be a few different shapes for it if you're interested. And just type it out and see what kind of nodes it is. Triangle. SF2D. Where's the triangle? Okay, triangle SF2D. So what we'll be doing here is I'll do a combine SDF. And then I'll just try combining SF2D, and I'll just try combining this triangle and circle to see if I can get sort of like a shape. Okay, this is the shape we got right now. Okay, I think I'll just keep continuing this. So I'll do a domain repeat 2D. Oh wait, I want to mirror this domain mirror SF2D, and I just connect this one here and then connect this one here. And I want this guy to mirror not in that direction. Okay, yes, this one. I think I saw something like this on Star Wars. Anyways, then I'll do a domain repeat SF2D, and then I'll let this guy repeat on the X and Y axis, wrap X and Y. And right now I think the scale is yeah, I think I'll make a little bit bigger, like 1, okay. And then however, I don't like the fact that the pattern is too big, so I'll add a scale on draw SDF and to make this scale really small so that we can see more dense pattern repeating. And we can actually rotate these if you want, so that if you have certain patterns that if you want to change a pattern, you can change it on this SDF in real time. We can also change the color here. I'll just keep it red, or maybe blue. No, I like it red. Okay. And then last of all, I'll add a domain distortion. Domain distortion SF2D to add sort of like distortion here. So in default, without connecting anything, it gives you this really not nice distortion. So we'll add a noise SF2D source here to get some sort of, I don't know, it has to be a VF2D noise. So we'll be connecting this one here, and then add a bit of frequency, distortion strength, so that it gives you a stronger distortion. And if you want to change the distortion pattern, you can change it by amplifying this, or changing the center, or changing the shape. So there's quite a lot of things you can do here. So yeah, I think if you screen capture this, you can actually create a really nice looking texture as well if you want to print on your t-shirt or whatever. I think this is a really good way of starting that. Okay, so this was a quick one, but it was it for today. Thanks for watching my FieldTrip tutorial. It's been a lot of fun working on this. From next tutorial, I'll be more focused on like small techniques that I've been using for my past works. So right now, until now, I've been following like FieldTrips or particle packs, or like Direct11 or Instance Noodles pack, which was basically based on really cool packs that they created. But from now on, I'll be sharing more of like a technique rather than how to use the pack, because that might be more useful for some of you. So yeah, thanks for watching. I'll see you next time.